So what happens, how do we get the impulse, how do we get a nerve communicating to another nerve? So the job of these guys is to communicate from one cell to another cell. So basically what we have, here's our dendrite, right? Here's our cell body, here's our axon hillock, and then here's our axon. This guy, it's going to get some type of a signal from another nerve, and it's going to cause this guy's chemical composition to change, and it's going to generate an action potential at the axon hillock. And then this action potential is going to spread down the nerve. And how does it spread down the nerve, guys? Depolarization, right? So if you think of our action potential that you've learned, this action potential is occurring at this area first, then this area, then this area, then this area, then this area. It is going down the axon. What prevents it from going up towards the cell body? How do we get the action potential going in one direction only? Inactivation of the sodium voltage gated channels. Okay. So the fact that they're inactive and they can't open again for a certain amount of time means that that charge goes in one direction. What happens when it gets to this terminus, okay, or this axon terminus or terminal button? There's multiple names for it. You have a neurotransmitter that's released. And this neurotransmitter is going to bind to this other nerve and get this guy excited. Or it's going to bind to a skeletal muscle and get that guy excited. Okay? So when these guys get excited, they can release neurotransmitters that can excite the secondary cells in that whole chain reaction. It can be another nerve. It can be skeletal muscle. It can be smooth muscle. It can be cardiac muscle. It can also have an inhibitory effect on those muscles as well. So depending on what neurotransmitters release and what receptors binds to, that dictates what effect it has on the secondary side and the chain of command. Okay, so let's take a look at the steps involved with this. So you get depolarization down the axon until you get typically around the terminal button. And what happens here is that once you get the action potential in this area, you have calcium voltage gated channels that pop open. And calcium is then going to rush in to that cell, to that terminal button. When calcium rushes in, and you can see this as 1, 2, 3, it walks you through it. So when calcium rushes in, it's going to cause these neurotransmitter-filled vesicles to dump those neurotransmitters into the synaptic cleft. So these vesicles have neurotransmitters in them, and they're located in this region of the nerve axon. When calcium floods into this area, it doesn't bind directly to the vesicles, and I don't really care that you know that, but it causes some type of cascade reaction, if you will, or secondary messenger system to allow these vesicles to exocytose or release the neurotransmitters. And so what happens is these vesicles go to the membrane and they merge with the membrane and dump the neurotransmitter into the synaptic cleft. Notice the synaptic cleft is the region from one nerve to another nerve. And you can see that the synaptic cleft is very small, okay? It's not very big. So these neurotransmitters diffuse across the synaptic cleft and bind to receptors on the postsynaptic